Okay, good morning. Welcome to
FamilyMath 1046.
FamilyMath 1046. So this is a really interesting thread I saw on Twitter earlier in the week by Zachary Binney. He says the FDA has approved its first antibody test for COVID-19, so the coronavirus, from a company called Cellex. It theoretically tells you if you've had it and are, as far as we know, immune for some time. Sensitivity is 93.8%, specificity is 95.6%. Sounds great, right? Well, sort of. Have you ever heard these terms, sensitivity and specificity, before?
No.
No, but I'm guessing they relate to how some measure of how good the test is, like how accurate it is.
Okay, well, by luck, I was able to pull up the Wikipedia page for sensitivity and specificity. So what does it say sensitivity is?
The probability of detection
Okay.
measures the proportion of actual positives that are correctly identified as such.
Okay.
So, like how many of the people who have it are identified
Okay.
out of the total number?
So true positives to all positives.
And what does specificity mean? Well, wait a minute. Sensitivity is not true positives to all positives.
So
It's
it's
the-
actual positives that are identified as positives.
Right. We'll get to that other measure in a second. How about specificity?
measures the proportion of actual negatives that are correctly identified. So, I guess that's basically the opposite. It's how good is it at identifying who doesn't have it?
That's right. So for simplicity, back in the original tweet, let's just pretend both of these numbers are 95.
Right.
And so that's going to say that 95% of the people who are positive are going to test positive on this test, and 95% of the people who are negative are going to test negative. Okay, so, if we were going to really deeply dive into this, we'd want to use these numbers exactly, but we're just going to do an overview, so we'll pretend they're both 95.
Yeah, it's pretty good for the first test. I mean, it's not great, but I don't really have anything to compare it to. Like, we don't have like a test. At least I don't know of any tests that have numbers.
Yeah, well, that's fine. It's a new concept. So he's gonna what he's gonna show in this thread is an interesting potential problem. So if only a small number of people actually have it, which is what we think now, only a small percentage of people have it, a positive antibody test isn't that likely to mean that you're immune or that you have had it. So he gives this example. If only 4.5% of the U.S. has had the virus, the test having a positive on the test only means you have a 50% chance of really having had it. Does that make any sense to you? Like, why do you think that would be the case? So we're getting it 95% right for both the positives and the negatives, but yet if only, let's say, 5% of the people have it, then it's only roughly a 50-50 chance that if you have a positive on this test, then you actually had the virus.
I guess it's because that we have basically 95% of the population doesn't have it. So if everyone tests, the test will say 20% of the population has it. Or not 20%, 5% of the population.
Well,
Okay.
So
Why will it say 5% of the population has
well,
it?
it has a 95% success rate or specificity. I don't remember the term. So if you test everyone, it will say, won't it say that 5% of the people have it? Because is that what that means?
Well, we're going to have to look into it a little more carefully. We're going to have to look at into the people who have it and the people who don't have it. So how many of if 5% of the people have it, how many are going to test positive? What percent of those people are going to test
So
positive?
95% of
95% of-
those people.
Okay. Which is 95% of 5% is very roughly
Like it's like between 4.5 and 5, like 4.8, 4.9%.
But we could say it's roughly 5% of
Mhm.
those so that's roughly 5% of the population that's going to test positive there. And then if 95% of the people don't have it and we test them, what percentage of those are going to show up as positives by mistake?
It's another 5% about.
All right. So that's 5% of the population there again,
Mhm.
roughly. So do you see why it only means you have about a 50-50 chance?
Yeah.
All right. And then, so he has this interesting chart about the percentage of people who have it versus how accurate the test is. And so at 5%, which is right in the middle there, that's goes up to about 50%. If 10% were truly infected, the positive antibody test has a 70% chance of being right. If 30% are infected, then it's about 90% chance.
So it gets better with more people that are infected.
Yeah. So does this surprise you?
A little bit, yeah, because at the beginning it seemed as if 95% sensitivity and 95% specificity seems like really good numbers.
Yeah, you're only making a mistake 1 out of 20
5, yeah.
times, it seems like. But it turns out to not, if only a small number of people have the disease, it turns out not to be good enough. So let's dig into those numbers now.
Okay.
Okay.